Hi there. Today we're going to talk about Lesson 98. And Lesson 98 is all about scale and scale factor. Scale is usually stated as a ratio. All three of these are examples of scales and scale factors. You would say them all exactly the same way even though they're written differently. 1 to 24, 1 to 24, and 1 to 24. Okay? They all represent scale factors. If the scale of a model train is 1 to 16, or 1 to 16, or 1 to 16, and the length of the model train is 120 inches, how long is the actual train in feet? Now, you're going to be seeing a lot of these kind of problems. They are fodder for word problems. Typically, you're going to see word problems that work with scale factors, so don't be surprised. So you would set it up like this: 120 inches times the 16, because 120 inches is the model, 16 is the scale factor, so it's going to be 16 times larger. That's 1920 inches. This is inches. Now, I believe that the question asked for feet. So what would you have to do to turn it into feet? Well, yeah, that's right. You would have to divide it by 12. So both of these sides I'm dividing by 12, okay? Divide by the number of inches in a foot, and you would get the answer that if the model train is 120 inches long and a scale factor is 1 to 16, then the actual train is going to be 160 feet long, which is 1,920 inches. So, not too bad, not all that hard. We do a lot of these. That's one of our favorite things that we do. Now, we can also use ratio boxes and ratios and scale factors to compute missing measures. You're going to have a lot of these. I call these, some of them we call tree and shadow problems. Sometimes we just call them missing sides problems. Okay, so you have a scale. It's 1 to 16. So actually this would be written as 1:16. Okay, and we know that the model measurement is 120. What is the real measurement? Okay. So this is how we actually could compute the length of the train using a ratio box. So this is 1 to 16 equals 120 to L. Here's our numbers right here. 16 times 120. That gives you 1,920 inches. And that just gives you the inches, remember. Then you have to take that and divide it by 12, and you get the feet. Now this is using a unit. So we're taking 1,920 unit conversion, 1 feet, 12 inches. Then you can cross out the inches. So you end up with 1,920 times 1 foot over 12. You divide, and you end up with 160 feet. We still get the same answer. Again, with math, you can do things about 25 ways and still get the same answer. Okay, note the graph of the relationship between measurements of a scale model and the actual is always a straight line and has a positive slope. It'll always have a positive correlation. If the model gets bigger, then the actual is going to get bigger. So it's going to go up, same. As long as a car or building is built to scale, the measurements will also always show the same scale. And the graph of that would look like this. This would be the actual size in feet. This is the model size in inches, and the graph's going to look like this. And it will start at the origin. Now, it's going to be a first quadrant graph because you're not going to have a negative size, right? So it would start here and go up like that. So the bigger the model gets in inches, the bigger the actual size in feet is going to be. Okay? I would definitely draw that in your notes. Okay. We solve most problems using scale. We solve most problems using cross multiplication. You've seen that already. Let's say we have a model of a car made from clay. And you know, by the way, for the information, a lot of them used to do that. They used to make the model of the car first, any car, out of clay, and they would get all their dimensions. They would take that clay model and they would measure it, and they would get all the dimensions off of that clay model, and then they would use it to make a larger scale of the car, and eventually they would use that to make an even larger scale, which actually turned out to be our real size car. Let's say the model of the car made from clay has a scale factor of 1 to 40. Okay? If the actual height of the car is 4 feet 6 inches, what should the height of the model be? Now, this is working a little bit backwards, I guess, but the height of the car is 4 feet 6 inches. What should the height of the model be? So, we're going to set ourselves a box, okay? And our box shows this, the scale factor is 1 to 40. We don't know the height of the model, but we do know the height of the car. Now, note, I did change that to inches, okay? Because it's kind of hard to work with 4 feet 6 inches. A mixture. It's 4.5 feet, but it's just easier to change it all to inches. So we would have 1 over 40 equals r over 54, and of course you would cross multiply to solve that. So you have 1 times 54 equals 40 times r. Then you would divide both sides by 40. And what you would end up with is r, the height of the model, is 1.35, or 1 35 hundredths, or 1 7/20 inches tall, which seems like a really precise measure, but when you're talking small, that would be about typical. That would not be out of character at all. Okay? Remember, model things are small, typically very small. Okay. Now, similar triangles and missing sides also fit into the scale factor talk. Take these two triangles. They look the same, basically. They both have right angles. And we're going to compare these two and find the scale factor between the two. So I just chose to compare the hypotenuse of both of them. And this is what I did. I went 17.5 to 5. I want to know how much bigger is this. What do I have to multiply this by to get that? So I took 17.5, divided it by 5. I end up with 3.5 is my scale factor, or 3.5. So the scale factor is 3.5, or 3.5, or 7 to 2. Okay? You can select any two corresponding measures or dimensions to compute scale factor. Any two, as long as they are corresponding. Now, corresponding means that they're in the same position. We'll go back to this, okay? 3, I'm going to put a square around it, and 10.5 are corresponding sides or measures. I'll put a diamond, or let's put a pentagon around these two sides. Those are corresponding. So you could take 10.5 to 3, and you could take 14 to 4. And all of those would give you the scale factor of 3.5. Okay? So that's kind of interesting, and it really does work. It does work. Okay, once you have scale factor, you can find dimensions, meaning length, width, and height. You can find area, only you must square the scale factor and then multiply. You can find volume, and you must cube the scale factor and multiply. Okay, I'm going to give you an example, show you an example of finding volume this way. Okay, we have a cube, and you probably should draw this in your notes. I have a cube that's 3 by 3 all the way around. Everything is 3. You have a cube that has edges that are 3 inches in length. Its volume is 3 times 3 times 3, right? Because 3, length, width, height, 3 times 3. Okay, so its volume is 27 inches cubed. That's what its volume is. Now, if we were to draw or create another cube using the scale factor of 2, I want to know what the volume of that cube would be without drawing it even. Can we do that without drawing it? Well, if we want to find another cube and its scale factor is 2, we have to take the scale factor, which is 2, and cube it. So we go 2 to the third power. So 2 times 2 times 2 is 8. And then we're going to take that 8 that we got from here. We're going to multiply it by the first volume that we got, which is that 27 for the smaller one. 8 scale factor cubed times 27 equals 216 inches cubed. Now, if you don't believe me, which you might not, I'm going to show you. Okay? So, remember that that cube was 3 by 3 by 3 by 3. And the scale factor is 2, which would mean then those sides would now be 6 by 6 by 6, right? Is that correct? 6 by 6 by 6, yeah. 2 times 3 is 6. So now your cube is 6 by 6 by 6. So the volume of that cube would be 6 times 6, which is 36. Take that times 6, which is 216 inches cubed. Well, let me see here. Wasn't that what we got this way too? So, you can do it either way. You can redraw it, try to figure out the dimensions, or you can simply just cube the scale factor and multiply it by the original, and you'll have your answer. So, this also works for area. So if you found the area of something and the scale factor was 3, you would take 3 times 3, which would be 9. Take 9 times the original area that you found, and you would find your new area of the new figure using the scale factor. Thanks a lot, folks. I hope this helped. If you have questions, ask me in class. Have an awesome day. Bye.